In previous classes, we have seen how to create structure, how to create class, what are the difference between structure and classes, and the difference between methods. There are two variety of methods, like one is the type method or class method. Another one is instance method. Class method should be called on top of class name, and instance method should be called on top of instance name. Instance means object. Now, the methods, we are having two variety of methods. Similarly, we are having four variety of properties. Four variety of properties. One is a stored property. Another one is the lazy stored property, computed property, static property, or type property. We have seen type method, right? Type properties also we are having. We have type properties as well. Okay, static method or class method or type method, how did you declare? By using static keyword or by using class keyword, right? Similarly, we can also have static properties. Let me show you. Okay, let me create new file here. Multiple files I'm taking here. Command N and take a Swift file. Or else you can take, let's try this Cocoa class. Vehicle. I'm just removing this. Enum we have and class also we have. I just copy and paste it. Okay, or else to make it clear, let me declare here itself. Remove this. Move to trash. Fine. I'm having vehicle class here. These are the properties which we have used so far. Similar way, these are called stored properties, which stores the values. Stored properties. These are stored properties. And let me write few methods. My instance method, or else move is a method. Let me write one more method. Print moving. Let me write one more method. This is going to be static method or type method. Static func. Show detail. Show detail. It is basically vehicle. Simply I'm vehicle. This is a type method or static method or class method. This is the instance method, which can be called on top of instance only. These variables are instance variables, we can say, are properties. Properties are of four types. These are of four types. These are instance variables, also we can call. Okay, instance variable means on top of instance. On top of instance in the sense, on top of vehicle, on top of object only, right? We are able to access them. My vehicle dot color equal to, I can put another color, red. I can put that here after creating the vehicle. Okay. My vehicle is an instance, color is instance variable. Since we are able to access that this property on top of instance, so it is instance variable. Okay. In instance variable, there are four types of instance variables. Basically, there are three types of instance variables and one type of brand manufacturer is string. Okay, this is a type property or static property. type property or static property. This is static method. Since we are declaring a method with a static keyword, it is static method. Since we are declaring a property with a static keyword, this is static property. Static method can be called on top of, let me take my vehicle equal to vehicle number of wheels, four-wheeler I want, color equal to color dot black. Okay, this is instance. Vehicle is class. Vehicle dot show detail. Show detail is a static method. We are able to call on top of vehicle. Similarly, we're having a property vehicle dot what is that? Manufacturer. Vehicle dot manufacturer. Okay, Audi. On top of class name, I am calling, since it is static property or type property or class level property. Only static we have put. So you need to access that by using classes. Simple. This is instance method, right? Instance method must be called on top of instance. My new vehicle dot move. My new vehicle dot show detail. Show detail is not populating because that is only accessible by the class, but not by the instance. Okay, these are stored properties. We say generally these are called static property or type property or class level properties. Static properties, type properties, class level properties. Very important. In interviews they will ask you what are the different types of properties we are having. We are having four variety of properties. One is stored property, another one is static property, lazy stored property, and computed property. Okay, these are the stored properties. By default, whatever we have declared so far till today are stored properties only. Today we are declaring static property or class level property. Now let me show you computer property. Computer property. Let me declare where description is of type string. Here there is some curly braces where I need to return the string or return vehicle is of, there's a number of wheels, number of wheels, four, four-wheeler vehicle of color of black. Let's run it. Yeah. Here description. This is called computer property. Computer means calculator, right? Computing means calculating. Whenever you access this property, that time this value is calculated. This value is calculated. Here the value is depending on some other properties. Here number of wheels we are using and color also we are using. Computer property calculated as and when you access it. Whenever you are accessing it, then only that is calculated. Okay, here my vehicle I am having my vehicle dot move. I'm just printing my vehicle dot description. My vehicle dot description. Here I'm having four-wheeler and black color. Four-wheeler of black color. Four-wheeler of black color. If you modify the color here, after that I'm modifying my vehicle dot color equal to my vehicle dot color equal to let's say green, and again print the description. Access the computer property. See that the computer property gets changed. What is this? Let constant structure. It is variable. Here also it should be var. Here see four-wheeler vehicle of black color. After changing the property, after changing the color to the instance, color to the color of the car, color of the vehicle, when you print description, again it is calculated. Again it is calculated. Number of wheels is 4 and color is green. Okay, let me put in simple example. Class calculator. Let A is after int. Let B is after int. Let var computer means it gets calculated every time, right? So it should be variable. And let me make it structure to make it simple. Where multiply is after integer and returning. This is the computer property A star B. This is computer property. Addition A plus B. What happens whenever you access multiply, then only this block of code executes. This block of code executes. This computation will execute. Then the values, whatever current values are available in the A and B are calculated. Okay, you can also put this print calculating multiply. Here calculating addition. You can also put breakpoints whenever you use project, Xcode project. You can use macOS project. You can use this. No idea. Automatically the breakpoints are done. Okay. Calculator is one class. Let me create a calculator equal to calculator. I'm asking for the values 10, 20. And here I'm just accessing the values like printing print calculator dot multiply, print calculator dot addition. See, let me put the breakpoint and run it. What happened? Please enter a color. Okay, it is asking for the color. Let me stop this vehicle show detail. Let me comment so that only this line of code will be executed. Only calculated code will be executed. Run it. Here calculator is created. We have supplied initial value 10 and 20. I'm trying to see here next step. These are the controls for the breakpoint. Step over. Whenever this is called, you are calculating multiply. Next line. Return A and B. Returning. Again control came back here. Printing. It came to the next line. Go next line. Calculating addition. Go next line. Return addition. Go next line. Once the control came back, it came to addition. Print that 30. Clear? Whenever you access the property, then only the computation will be calculated. Then only the calculation happens. That is called computed property. Basically, the computed property depends on some other properties. It is depending on this property. It is depending on this property. Okay, let me change the values. To change the values, the structure variable should be variable. Here also it should be variable. Here also it should be variable, right? Let me change calculator. Calculator dot A equal to 30. Calculator dot B equal to 40. Now again try to print. Same thing happens again. This block of code will be called. Calculation happens again. This block of code will be called for the addition. The block again calculates the sum and returns. Okay, let me run it. Here step over. Okay, here this is continue. This is continue program execution. It stops at the next breakpoint. Okay, it is called next breakpoint is here. It is stopped again. Next breakpoint. Next breakpoint is here. Calculation multiply is over and printed. 10 into 20, 200. Returned. Calculation addition printed 30. 10 plus 20, 30. I'm changing the value 30, 40, and multiply here. Whenever you are performing multiply, comes here. What happened? How many number of times you call multiply? How many number of times you call computer property? Those many times this block of code will be executed. Okay, every time it calculates with the latest values. Here, see 1200, 30 into 40, 1200, 30 plus 40, 70. Okay, how many number of times you access those many number of times that is calculated, that is executed. Okay, we know three varieties of properties. One is stored property. These two are stored properties. These two are computer property. I can also put static property or type property. Static, let static where manufacturer of this calculator equal to this is type property. Yes, you. This is type property. How to access the type property? Type means calculated the data type dot manufacturer equal to Casio. Accessing on top of type. The final property what we are having is a lazy property. Lazy property, lazy stored property, or lazy stored property. Let's say I want to perform the same thing like result is of type integer. How to do this? Is this correct way? Result. Where? Not directly lazy stored property. Lazy. Lazy is a keyword which we need to use to declare a lazy stored property. Okay. Equal to visit must have been cannot count the value of type. Okay. It is. It looks like a computer property only. It has something. It is also having something, but here we have equal to is the extra thing, and this is the extra thing. Okay. Let me put on. Accessing lazy stored property. I'm writing here A and B. Okay. Here, let's say A minus B. Let's say A minus B. Assume that this is very big competition, big task. Just assume that it is very big task. So when do we use lazy stored property? This is heavy task. I don't want to perform this heavy task as and when you create the object. As and when you create the object here, the memory will be allocated for this as and when you create the instance. As and when you create the instance, that time the memory will be created even for this also. But here, lazy stored property, what it does is it will not calculate, it will not perform this heavy task unless you use it, unless you access it. Okay, whenever you need it actually, then only the computation will be performed. Let me show you here. Here I am having a calculator performing multiply and division, no, so multiply and addition, changing the value calculator. Let me perform the here. Let me perform a result like calc dot result. Here this is let me say what is that? Subtraction. Subtraction I have called. Here I'm changing the values and again calling the subtraction. Same thing, whatever we did, whatever, however we are accessing, even let me create access the stored property, that is calc.a. Here also calc.a stored property we are accessing. We are accessing computer property. We are also trying to access the lazy property. Okay. See what happens here. The difference between computer and lazy property are very, very important. Let's run it and see. I'm trying to access the computer property for the first time. Okay. It came here and performed the multiply, division returned, multiply is printed. Calculate, subtract. The lazy stored property I'm accessing for the first time. Okay. See, put here. It came here, accessing lazy property. I'm performing very big task, which is already subtraction here. Let's come back and print subtraction. 10 minus 20, it is minus 20. I'm setting the resetting the values 10, 20 to 30 and 40. 30 and 40. I'm accessing just printing the value of A, which is 30. Perfect. And I'm trying to access the computer property. Again, it came here and calculated and printed and calling subtract. See what happens here. What happened? Subtract is still minus 10. Why? That is the beauty of lazy stored property. Lazy stored property. It is now again didn't go here. It again didn't go here. Lazy stored properties are calculated only one time. Okay. Lazy stored properties calculated only one time. Actually, we are supposed to get 30 minus 40. It is 10. Let me put 30 minus 50 and see the result. Even I'm removing this lazy stored property. We're calling here subtraction. Okay, it is calculated. That is 10 minus 20, which is minus 10, and changing the values 30, 50. When you subtract, we are supposed to get 30 minus 20, which is the minus 20, and calculating 30 is a value.